Okay, so we're going to talk about how to lay out your drawings on an A2 sheet. Your plans and all four of your sections. This will work for your plans and your elevations as well. And we're going to talk about how we're going to do it at either 45 or a 30-60 angle so that you're laying it out in anticipation of drawing an axonometric later on, which we talked about in class. So the first thing that I do before I start to draw any composition is to sketch it out first. I don't want to just draw it directly onto a nice clean sheet of fine paper. I'd rather sketch it out, and I might sketch out multiple versions so that I can choose the one that works the best for me and the plan that I happen to have. First thing I do then is to draw a border. And I'm going to make that border roughly the same proportions as a sheet of paper, although obviously in this case it's not going to be. And it's also a lot smaller than an A2. So the plan that I had drawn from before, as you can see, is really not going to work. I'm going to have to either shrink or enlarge these plans that I developed for my shapes, just like you had to do a few weeks ago during the semester. Now, before I come back to that, I think the first thing I ought to do is think about my primary and secondary axes here. And I can look at the primary and secondary axes in a couple of different ways. Now, when I determine the axes for this plan, that's going to also then drive how I fold off my sections and my elevations from this plan. So I want to make sure that I'm using the right set of axes. I can use any axes that I want, but I want it to give me good opportunities to draw interesting sections or to draw sections that are more clear. Now I have this move that you see right down sort of the center or the heart of this plan, and it's a nice angle and it stands out and it's really dynamic, but it will likely not create a set of clear sections. If I use this as my primary axis, then my secondary axis is going to be perpendicular to that. And you can see with that primary axis and a perpendicular secondary axis, my sections that would be parallel to those axes would actually be fairly confusing inside of that plan. So what I want to do is choose a set of axes that make sense. You can see I'm cutting through apertures now. I'm able to view things in that room. I do have some angled walls, but most of it is pretty clear and logical. And then of course my secondary axis is just going to be perpendicular to that, just like that. And you can see that secondary axis then will give me these nice clear sections through things like the stair and the aperture there, and you can see how the secondary axis will allow me to cut more logical sections. So that's how I'm going to order this plan when I lay it out on my A2 sheet. Once again, we can see that the plan is going to be too big for this, but first thing I'm going to do is bring out my T-square and my drawing arm. Now, in class, in the CAD building, you do have access to the tables and the drawing arms, and I'm not sure how many of you have parallel bars at home or Maylines. Probably none of you, and I wouldn't suggest that you go out and buy them. I actually bought this T-square for myself. It's good enough for the next 3 or 4 weeks. And you can use it in the exact same way. You can't see the side of my table, but I just use the T-square on the side of my table, and I make sure that the bottom edge of my composition is aligned with the top of my T-square, just like you do in class. And then, even though online, when you look up axonometric drawings, what you're going to find is most of them are drawn using a 45 degree. We're not going to do that. When I was in school, and most of the architects I know, we didn't learn how to draw 45-degree axonometrics, even though it's a correct way to do it technically. You run into some issues, which I mentioned in class last week, and it can be less dynamic. Now, when you look at a 45-degree axonometric, which I'll talk about in a future tutorial, things do look less distorted than a 30-60 axonometric, but for some reason, architects like that distortion. It looks interesting. There may be other reasons. I'm going to research it, and I'll let you know if there are other technical reasons for this. Now what I'm going to do with my 30/60 is from the bottom of my plan, or my sheet, right along this edge, I'm going to move this back and forth until I find a place that I think where that plan is going to reside, more or less. I'm going to resize it in my head, and I'm going to find a place for it that allows me to have space in other parts of the drawing to draw or fold off those sections and or elevations. So I think this is a pretty good spot. I'm looking probably in the center, right at a third, and I'm just going to strike a construction line. Now, then I turn my triangle to the 30-degree axis, and you can see that 30-degree then gives me a kind of perpendicular line, and I'm going to find that sort of the center of my plan is going to be in this region somewhere, and I'm just going to strike that construction line. That should be drawn really lightly. It's not in this sheet, but I'm working kind of quick and I'm using pens, and you're drawing, these lines should be construction lines. And then I'm going to take my plan. I already understand where those axes exist now. This plan is much too big, so in my head I need to resize it, and so this thing is probably going to come down into here somewhere. Might be right around there. Something like that. And of course, because the stairs are going to be 1 to 100, we can imagine that the scale of this plan is also going to be 1 to 100. And so that's what a 1 to 100 scale plan at the kind of appropriate size would look like in relationship to the borders of the page, which gives me some room to make some other drawings. So first thing I'm going to do is I'm going to think about that primary axis, and I'm going to think about where I want to make a section cut and the direction that I want to look. And we're going to look in all 4 directions here, and I'm going to sort of lay out each. So I'm going to think about a section cut through this part of the building that looks in that direction. Now I talked about earlier, you can do this with arrows and other symbols, and you can look these symbols up online, and I'll show them to you also in another tutorial. But that symbol right there, that kind of fat black bar, is known as a tick, sort of architectural tick, and it tells me that that's the direction that I'm looking at. You notice that my section cut line and my primary axis line are parallel. They should both be parallel, and they should be both parallel with the ground line. Okay, so I'm going to draw my ground line parallel with my cut line, parallel with my axis line, and then I'm going to draw on all my elevation lines. These are all construction lines. I'm going to draw on the elevation lines for my stairs, my first floor, my sills, my headers, my ceilings, my roofs, and then I'm going to make perpendicular registration lines from every edge, and every corner in that plan that I see through that cut. And now you have this matrix here, and that's where that section will be. You want to provide enough space between the section and the plan so the plan can breathe. This could actually move out into this area a little bit more. And then I'm going to, along that same primary axis, I'm going to look in another direction, the opposite direction. You can see that line is parallel to the axis line. It's also parallel to the other cut line. It's also parallel to the ground line of that section, and it will be parallel to the ground line of this section. Now, I can move this out a little bit more. You see I provide a little bit more space. And again, I'm going to draw all those elevation lines for stairs, floors, sills, headers, ceilings, and roofs. And then I'm going to register perpendicular to that cut line all of the lines that register against edges and corners. And there's my section right there. You can start to see how this starts to lay out. I'm going to turn 90 degrees. See that square, all parallel and perpendicular. I'm going to turn 90 degrees, and I'm going to cut through this plan, and I'm going to look in this direction. So I can put a cut line there. Okay, and then I can bring my ground line out. Obviously, again, parallel to the axis is the section cut line, and then the ground line is going to be parallel to the section cut line as well. The axis is parallel to the section cut is parallel to the ground line. Okay, and I'm going to add in all my elevations. I'm going to register every edge, every corner, perpendicular to the cut line. And there's my section right there. I'm going to do the same thing on the other side. Make this section in a different location. Okay, and I'm going to look in that direction. Whichever way those ticks are looking is where I'm going to fold off. So I can pick it up. That's the ground. I'm going to pick it up and lay it over. That's going to be my ground line right there. Leave enough room in there. That ground line is parallel to the section cut line, and that section cut line is now parallel to the axis line. I'm going to lay in all my elevation lines. I've got the ground. I'm going to put it on my stairs, my first floor, my stairs between the first and the second floor, my second floor, my sills, my headers, my ceiling, my roof. And then I'm going to register all of the corners and edges that I cut through there. And you can see that's how I lay out my plans and sections. Again, I could probably have moved this in that direction a little bit, maybe more out here, and you can start to see how this starts to become balanced out. Now I do have a lot of empty space out here, but now you can imagine where we might get a density of the pattern when we put that underneath in here somewhere, and maybe some piece of the pattern that's doing something like that, maybe some piece of the pattern that's coming in like that, and we start to fill out with that pattern that makes a nice kind of interesting ground plane, and a kind of more cohesive composition. That is 60, that is 30, and that will set us up later on for a good 30, 60, 90 axonometric drawing.